In this demonstration, we're going to apply the normal distribution to find percentiles. We're going to work under the assumption that IQ scores of adults are normally distributed. We're going to calculate the percentile, the 25th percentile, and we're going to look at also the 75th percentile. And I'm going to show you how those two things are different. The top 25% is different than the bottom 25% of scores. And I'm going to show you how to locate each one of those on the normal distribution curve. We're going to use a mean of 100 and a standard deviation of 15 for our calculations. In our first example, we want to find the 25th percentile, and we want to find the IQ score that is separating the bottom 25% from the top 75%. So, as always, the very first thing I want you to get in the habit of doing is sketching your curve and marking off the location of the score or piece of information that you want to find. So where is the score that would separate the bottom 25% from the top 75%? So the score of interest in this problem is the bottom 25%. So we're looking at down here somewhere. Now, it doesn't need to be exact. You just need to have a visual cue as to where the bottom 25% might be. In other words, you need to mark off and know that it's not up here somewhere. Okay, so that's your cue of interest. So we need to know that it's not up there on the right. So your bottom 25% is down here on the left of the mean. So we're interested in this area down here. There's our bottom 25% of the scores. Our top 25% or 75% is up there to the right. Alright, so what are we interested in? Down here, 25% of the scores. So 25%, that's 25% of the area. We need to change that into a format that we can use on our normal distribution table. So 25% is going to be 0.2500. And just for the sake of information, let's write this up here, 75%. That's 0.7500. We don't really need that, but I wrote it up there just so you could see it. We need to pull out our normal distribution table of values for z-scores, so let's go ahead and get that out. Now take a look at your scores on your chart, and if you look at the normal distribution that's at the top of your chart, notice that it looks an awful lot like the sketch that you have drawn. This particular chart gives you the cumulative area in the left tail of your chart. So this area right here is what's given in this chart, up to the z-score that is marked. So we are looking for the area that is 0.2500, or the closest to that value that we can get. So you need to look in the body of the chart as opposed to in the outer column and row to find 0.2500. So if we can look as close as we can get to that value, to 0.2500, which I don't have the whole chart here, but I know that I have enough. I'm going to make it a little bigger so we can see it. 0.2500, as close as I can get, is 0.2514. And the z-score that is associated with that is negative 0.067. So the z-score that is associated with 0.2500, or the 25th percentile, is negative 0.067. And I did not mean to put that extra decimal in there. So that's my z-score. Now how do I convert that to the IQ score? Well, I need to plug that in to my formula to find the x that goes with it, which is the mean plus z times my standard deviation. And I just need to do a little algebra there and plug in 100 plus my z times my standard deviation. So the IQ score that cuts off the bottom 25% from the top 75% is 89.95. Now, let's take a look and see how this is different from the top 25% separating the bottom 75%. Again, let's mark off on our curve the information about which we are interested. So in this case, we want to know the 75th percentile, which is the IQ score separating the top 25% from the bottom 75%. So in this case, I want to know the top portion of data. I want to know up here. I want to know what's separating this portion up here. So I'm going to use the positive z-score chart. So I'm going to pull out my other chart that has my positive z's. Now remember, since I'm sitting right here, I'm interested in a z that's positive because I'm to the right of my mean. I could use my negative z-score chart, but then I'd have to subtract from 1, and I don't want to have to do that extra step, so I'm going to use my positive z-score chart. So let's label the areas that we have. Up here, I have 25%, which we have established is 0.2500. And back here, we have 75%, majority, which is 0.7500. So in our chart, take a look at the picture at the top, which is essentially our key, our legend. Notice the picture is telling us what portion of area is given in the chart. So our chart is giving us this cumulative area from the left up to our z-score. So it's telling us that this is the area that we want to look for because it's telling us that it's giving us from here to here. So this area is 0.7500. So that's the area we want to look for in the middle of our chart. So we want to look for 0.7500. So we want to find 0.7500 or as close to it as we can get. So looking for that value in the middle of our chart, let's see how close we can get. So I'm looking through and I'm looking for 0.7500, and it looks to be like 0.7486 might be as close as I can get. And that is 0.067 as my z-score. Or 0.67. So then I need to apply my formula once again to calculate the x that corresponds with that so that I have my actual IQ score. I'm going to move this out of the way. It keeps moving all of my drawings. So again, the formula is the same. X equals the mean plus my z times my standard deviation. And then I plug in and work a little algebra magic. 100 plus 0.67 times 15, which is my standard deviation. So 100 plus 10.05 equals 110.05. So even though our z-scores were similar, one was a negative and one was a positive, and that made all the difference in the IQ score that separated the bottom 75% from the top 75%. So our z-score that separates the top 25% up here is 110.05. So now you can see how to use the normal distribution to find percentiles, and you can see the difference between top percentiles and bottom percentiles.